Good morning, everybody. It's time for a wonderful morning on Chem 1105 with your host, me, Dr. White. All right, something I do want to talk about is a lot of you haven't handed in the PV equal NRT lab. Not the lab that was due yesterday, the lab that was due last week. Get it in today. It's 10 points. It's not that hard. If you need help, come to my office hour tonight. A lot of your grades are going to be really hurt if you don't hand in labs. Enough said. All right. And by the way, for those of you who have handed in the lab, thank you. And this morning I posted the scores for that lab on Blackboard. All right, let's get to work. Now, we went through what is of acid and base, and that is the Arrhenius theory. Doesn't explain everything. And remember, under Bronsted-Lowry, an acid is a proton donor. An acid is a proton donor. A base is a proton acceptor. A base is a proton acceptor. I got busy yesterday. I apologize. Let's see, today is Wednesday. On Friday, I'll go through examples of conjugate base pairs. All right, yesterday, but I sort of sped through this, but I'm going to go through it again because repetition is good for your grade, which I think you all are agreeing that's a good thing to have. And that is when we talk about acids and bases, there's strong acids and switches off, but this is good for the rest of your life to know. And strong acids transfer nearly 100% or 100% of its protons, H plus, to water. And examples of strong acids, most useful one is in this one, HCl, hydrochloric acid, and that's in your stomach. Here in organic chemistry, X is a halogen, other strong acids, HBr, HI. Now, a very important strong acid is H2SO4. And finally, another one, that's sulfuric acid, is nitric acid. And at least for HCl, H2SO4, HNO3, hydrochloric, sulfuric, and nitric acid. If I ask you, is that an acid or base? You should know that's a base. Excuse me, that's an acid. All right, now weak acids don't give up their proton that much, only about 5%. And probably the most important one of them is acetic acid, which I won't ask you to learn the structure, but I'll show it to you anyways in case you're interested. Now, this is one way in organic chemistry, which acetic acid is an organic molecule, which I'll talk about organic chemistry later in the semester. This is one way. We rarely, like almost never, use the empirical formula like H2SO4. We show either this or another way of showing this molecule, now Dr. White's showing off, is this where we show some of the bonding. All right, acetic acid, 4% of this. And plus, this is about 96% water equals vinegar. And you can use vinegar, which is a very dilute solution of acetic acid, because vinegar or acetic acid is a weak acid. if you had a 4% solution of the strong acids and you had that in some way in your mouth or ingested it, you'd be in the hospital very quick. Do not do that. All right, there are also strong bases and weak bases. The two common ones are sodium hydroxide, potassium hydroxide. And on a test, you should know if I put NaOH, is that an acid or a base? Let me see if I'll get it right this time. It's a base, same as KOH, potassium hydroxide. If I put this formula, is that an acid or base? Hopefully you will say it's a base. Now, another base, well, you can have weak bases. As I mentioned yesterday, sodium bicarbonate, NaHCO3, which is found in baking powder. Is a weak base, which is why you can use it in cooking. Now, yesterday I talked about, but let's go over it again. Water is an amazing compound. And hold on one second. And water can react with itself in an equilibrium. That's where you have a forward going to the right reaction, at the same time going backward to the left. And I've shown the size of the arrow. Most of it stays here on the right, on the left, but some goes to the right. And this is an extremely important reaction in our daily life. And what you form is hydronium ion, and hydroxide ion. Now, since unfortunately I don't teach equilibrium in this class, there are certain constants you can create for equilibrium. And for that, by the way, new material, didn't do this yesterday, for the following reaction, there's a number, a constant called Kw. I wish it was named after me, but it's called water ionization constant. K is constant, W is for water. But I still like to look at it and think, oh, it's honoring me. And ionization constant of water is defined as the concentration of the hydronium ion times the concentration of the hydroxide equals 1. I should have here 1.0 times 10 to the minus 14 at room temperature, 25. And you should know how to use this. And in the past, you'd have to memorize this. I will be giving you this information, important information, test number 4. And don't forget, on Friday, speaking about upcoming tests, I will be going through the solutions problem set. Make sure you do them. Test number 3 is coming up soon. All right, let's have some fun with the ionization constant of water. Oh, I keep on doing this. I remember this is the print class. And the following is, what's the hydroxide concentration? Remember, this means concentration which really means moles, solute, whatever in the bracket, per 1,000 milliliters. So what is the hydroxide ion concentration if the hydronium ion concentration is 1.0 times 10 to the minus 4? So what are we trying to find? Hydroxide concentration. What do we know? This. So how do we proceed? Well, do you know a relationship between hydroxide and hydronium? And the answer is yes. And this is equal to 1.0 times 10 to the minus 14. So how do you solve for hydroxide? You want to get rid of hydronium ion, so you divide by it. Anything divided by itself is the number 1. And anything divided by itself cancels out. And now put in this number because I have it up here. And I'll do the math in my head. I'll show you how I can do that. And the answer is this. And that's how you do it. Now, 1.0 divided by 1.0 is 1.0, but 10 to the C divided by 10 to the D equals 10 to the C minus D. In this case, we had minus 14 minus 4, and that equals minus 10. Part of this, knowing this and doing it quicker in my head, not in a calculator, was I was brought up using a slide rule before calculators were invented. We did have cars and televisions. Even though I remember when television was only black and white and they came out with color TVs. And my friend got one before our family did. I used to go over to his house to watch it. All right, let's try now. You might want to ask, why are you doing something like this? Because before pH, how would you know if something is acidic? You'd have to look at what's the concentration of hydroxide and hydronium and which one is bigger. And that would tell you if you have a basic, acidic, or neutral solution, which is why people went to pH. But let's do one. I'm going to let you do one. Now, important information, you'll be given this. And now I'm going to let you try this. Am I nice or am I nice? Don't answer that. And let me launch a poll. So I can't see you. Most of you don't have your webcams on. So I can't tell if you're done or not. All right, I think everybody's done. So let's get to work. What are you being asked to find? The hydronium ion concentration. What are you given? The hydroxide ion concentration. Remember, in a bracket, that means moles per liter concentration of whatever chemical is in there. So now, how do we begin? We use this, that the hydronium ion concentration times the hydroxide ion concentration equals 1.0 times 10 to the minus 14th. And now, if we want to solve for this, we have to get rid of hydroxide. How do we do that? Well, remember, anything divided by itself equals the number 1, cancels out. So I want to get rid of hydroxide, I'll divide by it. And that would cancel out, be number 1. However, anything you do to one side, you have to do to the other. And now I have the hydronium ion concentration equals 1.0 times 10 to the minus 14th divided by hydroxide. And I'll put that number in. And remember, we took the time to write it right here. And if I do the math, this is the number I get. And that's how you do it. So you should be familiar and know how to do this. Now, this is quite important, so let me go through this again. If that is, an acidic solution is a solution in which the concentration of the hydronium ion is greater than the hydroxide. And that's what this means using the math symbol greater than. And right now in your stomach, the liquid in your stomach is acidic, and therefore you know the hydronium ion concentration is greater than the hydroxide. Now it's acidic because that helps break down your food, but the chemical reason for this class why it's acidic is this: hydronium greater than hydroxide. Now, basic solution is a solution in which the hydroxide ion concentration is higher than the hydronium, which you could write like this. And again, this is the greater than symbol. And I should point out, I won't ask it on a test, that this is sometimes called an alkaline solution. And that's how the name alkaline batteries came about, because originally batteries were acidic. And then they found when they used different chemicals that were now basic, alkaline, you have a better battery for things like a AA, AAA, C, or D battery, for those who know battery sizes. Now, a neutral solution is when the hydronium ion concentration is equal to the hydroxide ion concentration. And if you had ultra, I'll say it again, ultra pure water, this would be true, which you can't get your hands on. But if you did, that's what it would be. Now, dealing with hydroxide and hydronium ion concentration is quite, I don't know, difficult or not easy. That's a better way of putting it. And someone came up with the pH concept. And the pH concept, there's a pH scale and small numbers used to specify the hydronium ion concentration. And this is important in an aqueous solution. And as I went through yesterday, but let's go through it again. pH equal minus the log of the hydronium ion concentration. Now, this will be given to you. Important information, test number 4. I've been saying that. Let's find out if I'm lying to you or not. You never know, I might. I don't, but if you look at important information, test number 4, you see I'm not lying to you. I give you the pH, and I also give you KW, not named after me, but I like it, wish it was. And I've got to change this because this should be 1.0. And so you don't have to memorize this, but you do have to know how to use it. All right, now my gift to you, and it's a nice gift, I hope you enjoy it, is if the hydronium ion concentration is 1.0 times 10 to the minus x, and you put it in there, then the pH is equal to x. So as long as this is 1.0, if it's not, then you have to use a calculator, calculate the log, and then multiply times -1. Don't forget this, but you'll never have to do that on my test or the final. Actually, test number 4 or the final. And that's my gift to you. Now, the pH scale is 0 to 14. The lower the pH scale, the more acidic it is. The higher the pH scale, the more basic it is. And this is probably the most important thing I'll teach you this semester. pH goes from 0 to 14, never less than 0, never more than 14. At 7, we have neutral pH, or I should say neutral solution. It's neutral. Below 7, you have acidic solution. And above 7, you have basic solution. And the lower the number, below 7, the more acidic the solution is. The higher the number above 7, the more basic the solution is. And you should know this. Ooh, I better do this. And I hope we get the picture or get the hint. This is very important to know. So this is the pH scale. Let's have some fun with pH scale and pH. And let's look at the following. If the hydronium ion concentration, H3O plus, is 1.0 times 10 to the minus 3, what is the pH? And is it acidic, basic, or neutral? Well, how do we do this? We're trying to, first of all, find the pH, and we're given this. And you will be given in test number 4 this. So I'll put that number in. And now, remember, when this is 1.0 and it's 1.0 times 10 to the minus x, in this case, x is 3, because remember, it's 1.0 times 10 to the minus x, the pH would be 3. But also you have to figure out is acidic, basic, or neutral. And you should know, this is one of those things I'm going to ask you to memorize. I've cut down dramatically the amount you have to memorize for this class, really way down. And notice 3 is below 7, which makes the solution acidic. And that's how you do it. Oh, let's do another one. I'm going to let you try it. Your turn. If the hydronium ion concentration H3O plus is 1.0 times 10 to the minus 11, then what is the pH? And is it acidic, basic, or neutral? Go. Go. That was polite. Sorry. And the votes are coming in. Remember, it's okay to vote no if you're not done. I think everybody's done. So I better get to work. So let's look at this problem. 5 points. If the hydronium ion concentration is this number, what is the pH? So the first thing we have to figure out is, what is the pH? We're given this. And now, what do? Well, an important information, you'll be given this. Oop, got ahead of myself. Got really ahead of myself. pH equal minus log of the hydronium ion concentration. And here, that's equal to log minus the log of 1.0 times 10 to the minus 11. And my gift to you, when this is 1.0, the log of 1.0 times 10 to the minus x is x. In this case, x is 11. But we still have to find out, is it acidic, basic, or neutral? And deja vu all over again. Does this look familiar? If I do it enough times, you'll remember it. And remember, 7 is neutral pH. Above 7, it's a basic solution. Below 7 is acidic. And I hope you all agree 11 is above 7. So this is a basic solution. Oh, this is fun. Let's do another one. All right, let's go through this. If the hydroxide OH minus concentration is 1.0 times 10 to the minus 10, then what is the pH of the solution? And is it acidic, basic, or neutral? So if I look here, I'm trying to find a pH. And I'm given this. And I know from important information, test number 4, pH is minus the log of the hydronium ion concentration. Uh-oh, this is not the hydronium ion concentration. What do I do? Well, you need 2 steps. And first of all, you have to determine this. Second, determine or calculate pH. So how do we do number 1? Well, do you know the relationship between the hydronium ion concentration and the hydroxide? And the answer is yes, you do. And that is Kw, no, not really, is equal to the hydronium ion concentration times the hydroxide equal 1.0 times 10 to the minus 14 at room temperature. Well, if I want to solve for this, I have to get rid of that. And how do we get rid of something when you're multiplying? You divide by that. Whatever you do to one side, you have to do to the other. This cancels out because anything divided by itself is the number 1. And now we're left with this. I know what the hydroxide OH concentration is because we took the time to write it down there. 1.0 times 10 to the minus 4th, or 10th, I mean. I got ahead of myself again. And do the math, and this is my answer for this equation. Now, are we done? No, because we're trying to find the pH. So now we have to do step 2, determine the pH, and using pH is equal to minus the log of the hydronium ion concentration. And pH equal minus the log of the hydronium ion concentration equals minus log. And here we figured out what that is. 1.0 times 10 to the minus 4th. And now, remember when this is 1.0, 1.0 times 10 to the minus x, this whole thing is equal to x, in that case 4. And we still have one more thing. So the pH of the solution is 4. Is it acidic, basic, or neutral? And if we look at this chart, we'll see pH 4 is less than 7. So this is acidic. And remember, the key to this is you had to do 2 steps. If you're given the hydroxide 8 points. You have to first determine the hydronium ion concentration by using Kw, the water ionization constant, and solve for the hydronium, which is what we did. And once you get that value right here, you put it into this equation to get the pH and to determine if it's acidic, basic, or neutral. You should know this. Of all the things I'll teach you this semester, this is probably one of the most important right here. What's acidic, what's basic, what's neutral. Now, interesting when we talk about acidic, basic, or neutral, think about all the condiments you put on a hamburger or hot dog. What are they? Well, for a hamburger, you can put on ketchup. I'm not a big ketchup. I like barbecue sauce, but it's the same thing. In Chicagoland, we never put ketchup on a hot dog. Oh, yuck, yuck, yuck. You can tell I was brought up in Chicagoland. But we do put mustard. You can put that in a hamburger too. And both of those contain vinegar. Let's see if I'm telling you the truth. You don't know, I might be lying to you. And if you look on your screen, thumbs up, people. Can you see nutrition on your screen for Heinz? Thank you, Ruben. If you look over here, ingredients, tomato concentrate from red ripe. I hope they don't use non-ripe tomatoes. Oh, I didn't know they put butternut squash in there. But here we have distilled vinegar. That means pure vinegar. And what that means is there's acetic acid in vinegar, which makes it, guess what? Acidic. And let's do one more while we're in the area. And hopefully you all see the Heinz yellow mustard. I don't like this type. I get a better one. Coops is better. And there are a few others that are better than Heinz mustard. And if you notice, the first ingredient is water. I bet you never thought of water as a chemical. Well, it is. And the next one is, oh, look, it's here again, distilled white vinegar. If you think about it, which I'm going to make you do that, all the condiments you can put on a hot dog or a hamburger that comes out of a jar are acidic. I bet you can now astound your friends, neighbors, and loved ones, and you can tell them the next time they put hot dog with mustard on it, or if they put ketchup on a hamburger, or on either one, you put yellowish, boy, think of yellow mustard and relish. Don't forget, in Chicagoland, we use that super green stuff that glows in the dark, and those are all acidic. Why? Because there's vinegar in there, and vinegar is really a mixture of water and acetic acid. And think about a lot of the things in your home that have a real sour taste to it. And those are all acidic. Example would be lemons, limes. They have that sour taste. The pH is much less than 7, and they're acidic. And if I look at the clock, I've got about 30 seconds to go. So it's time for a public service announcement from your host, me, Dr. White. Hand in labs. Those of you who are doing it, thank you. Those who aren't, hand them in. If you need help, come to my office hour tonight, or stay after class on Friday or next Tuesday. I will help. You can ask some of your colleagues. I've already done that. You shouldn't be losing points. With that, I'll get off my soapbox. I just did a generation gap thing on you. And I'll say, we're done for today. Boy, did it go quick. Time flies when you're having fun with acids and bases and pH. And with that, I'll say